All right, so let's get started and create the first app, a Hello World app. How are we going to do it? In the IDE in Android Studio, we will create a new project for an app with basic activity. Let's start Android Studio. So by now you should have the Android Studio working, and this would be a good test, today's app, this Hello World app, as to how your setup is, if it's got everything we need. The first option here is create new project. We'll choose that. And actually, I'm going to change something in the slide. I'm saying that you're going to use basic activity. Let's change it to an empty activity. So I want you to choose empty activity, and then it will ask you to give it a name. So this is the convention. This is the practice we are going to follow. All the apps we develop in class, I want you to name them with your name in the application. I will show you in a moment how, and then suffix it with whatever the activity is. For example, we will be developing a game, the tic-tac-toe game, we'll be developing some maps application, etc. So whatever the application is will come at the end, and first there will be your name. And you will see why we do that. So let's do that. I'm going to choose the empty activity. So here it gives us so many options when you start, when you say new project. Let's look at this. So first of all, there are different tabs. There are apps for phone and tablet. So mobile devices like phones and tablets. Wear OS allows you to develop applications for the watch, wearables. Android TV, you can develop applications for Android TV. A lot of the smart televisions, so-called smart televisions that you buy these days, they run Android, some version of Android. You will be able to develop apps for those using Android Studio if you wanted. Automotive apps are things, a lot of cars these days. If you buy a new car, a newer model, it will come integrated with some sort of a mobile, interface, not mobile interface, but an interface like that of a mobile phone, which will have features built into it. And you can program things so that these become like apps for your car, specific to the car. And then the Internet of Things has its own. So for example, I'm just going to give you an example, a fridge that has internet connectivity. You could develop an app for it. So these are the possibilities Android Studio opens up for you. In this course, we will be focusing on phone and tablet apps, but the methodology, the tools, the techniques are the same. So go ahead and choose empty activity. There are others. You will see you could create a project without any activity. An activity is like a window. When you run an app, something appears on the screen. That is an activity. And then there are other types of apps. There is a bottom navigation activity right here. There is a full screen activity, which gets rid of the status bar at the top. Maps activity. There are activities that let you do things that are very specific. For example, allowing the user to choose settings. Every app has its, every app can have settings, user settings. For example, the app may have music, background music, whether to keep it on or off. Those kind of things will reside in a settings activity, and the Android framework gives us a generic way to include settings in any app. So these are the different things. We are going to go with an empty activity, and we are going to say next. The next page is where it asks you for a name, right? This is where I want you to change it to your name. I'm going to use my name, and then hello world. So you use your name and hello world. And make sure you do this because from time to time, I'm going to ask you to submit the work you do in class as an assignment. So this is how I identify them, and this is how I know that you have done the work. So that's the name, save location. It chooses a default location. If you don't like it, you can change it. It gives a package name by default. This, if you were creating an app to submit to the Google Play Store, this would have to be a unique name. So typically it's a reverse domain name format. So for example, here the domain name was example.com, so it got reversed com.example. You can leave it just like this. If you're working for a company, ABC Software Development, then it may be com.abc software development dot the name of the app. Language. So there are two choices here. There is Java and there is Kotlin. How many of you have heard of Kotlin? Java, many of you probably have heard. What about Kotlin? So Kotlin is a newer language. It's a it's less verbose than Java. It does not require as much coding, but it's fairly new. Most of the apps on the Play Store that you see today are all written in Java. We will touch upon Kotlin, but today we are going to use Java. So I want you to, if your default selection was Kotlin, change it to Java. Minimum SDK, mine says this is the latest API I have installed on my on my Android Studio. So I'm going to just use this Android 10Q. And it is telling me, see, this is another important thing. Why does it matter? Minimum SDK. Depending upon what you choose, the number of devices that your app becomes available to is it depends on that. So for here it's saying 8.2, meaning 8.2% of all Android devices in the world, approximately that number, are running this operating system or later. So your app will run on those, but not on the others. So generally speaking, you will choose a much older one unless you are using newer APIs. So for now, I want you to leave it as a API, whatever is the maximum it gives you. Leave it at that, and then we'll see how to change it. Because you can change it later on. We'll do that. So that becomes a learning activity for us. Now I will say finish and wait for Android Studio to do what it does. So it is going to create the bare bones of the app for us. So while it's doing that, let's look at what we have on the slide here. So we chose Java as the programming language, and we talked a little bit about Kotlin versus Java. And now what we'll do is we'll explore what Android Studio has done for us, look at the different folders and things like that. Now, this may be the first time many of you are looking at Android Studio. So let's see what's going on here. This here on the left, as I mentioned earlier, is the project navigator, and it tells us the different types of, different folders and what files are in them. So right now it shows us that there is a top level folder called app, and within the app there is a folder called manifest, there is one called Java, and there is a third one called res. Now this is not black magic. Every one of these things you need to understand. You need to know what these are. Manifests are where the metadata about the app is stored. So the first thing the Android operating system looks at when you want to run an app on it is the app manifest. This is an XML file, and this is what it looks like. If you double click any file, it will open here in the editor. And I hope this font size here is sufficiently large for you to be able to read in the videos. If it is not, you have to let me know, and from next time onwards, I will increase this font size so you'll be able to read it better. Alternatively, you can also, view these videos on a larger screen so that you are able to follow along. So this manifest here is telling a few things to the Android operating system. What is the name of the package? This is the name that we gave when we created the project. It is also telling us that this package contains one application, this application tag. And there are some parameters that this application conforms to, it behaves in certain ways. What is the application icon? What is the name of the application? You remember we gave on your Android Studio, you should see your name here and then the hello world. And some other things, you will learn more about these as we go along the course. And this is where one key information the Android operating system gets. Which activities are present in your app? Like I told you earlier, activities are like screens. They're like windows. On a regular computer, you can have different windows from the same application. So activities are like that. So here it is saying that there is an activity which is called main activity. And this dot simply means that they belong to this package here. So everything dot something, if we had a sub package, it would be mentioned here before main activity. And Android also activities can signal to the operating system what capabilities they have and what kind of behavior they assume through intents. And this here intent filter, it's telling the Android operating system that this is the main activity. It performs. So for example, if there was a task related to this activity, which, sometimes there are URLs, etc., that lead to an app, this is where they would end up. And this other one is a category this activity belongs to. It says launcher. Once again, what's happening here is this category, this declaration is telling the operating system, when you open the app, start this activity. You may have other activities, but it will start whichever one that says launcher, on launch, what to do. So this is your manifest. Let's look at what's going on in this folder Java. And you will see that there are two folders which are sort of here in my screen. It looks a little bit like light green background. Depending upon your color scheme, it may be different, but you can identify them by this lighter text, Android test and test. These are for automated testing, unit testing. Maybe you have heard of it. We'll talk about it later on in the course. And these are automatically generated. So we won't bother with them right now. They have some test files. What we want to look at is this one, which has this file called main activity. This is a Java class. It says main activity.java. And whenever you have an activity that in a mobile app, it must extend. Now, at this point, I would ask in a classroom, how many of you are familiar with Java and what this word extend means? So Java is basically designed for object-oriented programming. And a class that you declare can inherit behavior from another class. So in this case, this main activity inherits all the behavior of a class called app_compat_activity, which if we expand this, you see here import statement. If I click this plus, all the import statements get bundled in Android Studio Editor. And you will see that there are two import statements. One is importing this activity, app compat activity, and the other one was a bundle. And you will see both of these things being used here. So this main activity inherits app compat activity, and it does certain things here. At this point, I think what I want you to do is I want you to run this app. Now, to be able to run this app, you need to have something here. See, a run target. I have a target called Pixel 2 API. And this is what I'm going to choose. And if you don't have anything here, I will tell you in a moment what you need to do. So I'm going to run this app and see what happens. So that briefly something popped up. It said Android emulator. And this is the Android emulator. And this is my app running in it. And it says hello world already. I didn't even say anything. So what happened here is this app was compiled by Android Studio and run in a run target, which is this Pixel 2 API R, meaning Pixel 2 phone, Google's Pixel phone simulated on this computer with Android API R operating system. Now, if you don't have anything here, I want you to do this. I want you to click on this AVD manager. AVD is virtual devices, Android virtual device manager. And this will, if you already have a device, it should appear in that menu as well as here. And if this comes up empty, you can create a virtual device. So you say create virtual device. And then you choose what kind of device. In our case, we'll choose a phone. You can choose a phone model, whichever you would like. I already have a Pixel 2. Let's say I want to create a Pixel 3. It really doesn't matter for testing unless you want to specifically test on a certain device that is listed here. You have lots of options, including some older phones. Anyone will do basically. So let's say you are creating a Pixel 3, and then you say next, and then it's going to ask you which operating system, which version of Android you want to run on it. And you can choose one, and if there is nothing available, it will allow you to download one of the options. So you choose the latest one, in this case R, and then you say once you finish, gives you options. There are some advanced options here. Yes, show advanced settings. I don't think you need to do anything, but advanced settings will let you choose things like how much RAM you want to allocate to this virtual device, how much storage space. The defaults are generally very good, so you don't really need to go in there, but I wanted to show you. And then when you say finish, it will create that device. It may have a download, it may have a large download. So depending upon your internet speed, you may have to wait for some time. And once it appears here, you can close this and it should appear here as well. Okay, so that's how you will install a virtual device. Now, now my app is actually running because I gave the name as my name, Hello World. That was a previous test app I had. So this is what it says. There is another thing you could do, which is if you have an Android device, and I highly recommend this, if you have an Android device, use it. I have one here, and I'm going to show you how to use that for development and testing. So let's do that first. So emulator, this emulator here that we have, let's compare it to what happens when, for development purposes, you use an emulator versus an actual device. So using an actual device has advantages. Installation, loading, and reinstallation will be faster because it's not consuming resources on the same computer. It also gives you the same feeling of the, using the app, whatever app you're developing. A device allows you to, for example, touch and experience that instead of mouse clicks, scrolling by, swiping your fingers on the screen up or down. On the other hand, a device emulator has its own advantages. One is that you don't need to own any Android devices. If you don't have any, you can use the emulator. My recommendation is that Android devices are fairly inexpensive, and also you may be able to find somebody, a friend or family member, who has an old Android phone they no longer use. You can use it. You can do a factory reset on it, wipe out all data, and then use it for development. It's highly recommended. So at this point, I would ask you, what are some other advantages of using a device emulator compared to an actual device? So think about it, and maybe post something in the discussion board if you do think about and you think of some other advantages. So the question then is, how do you connect a device to Android Studio? In my Android Studio, I only see this pixel right now. What if I want to run it on this device? How do I go about it? That's what I'm going to show it to you. So I have a USB cable. I'm going to plug it into the device and see if it appears. Now, in my case, it does appear here. Samsung, it's a Samsung device. In your case, it will not appear unless you have certain settings on the device that you have enabled. One is USB debugging. So in your settings app on the device, find a setting that allows USB debugging and enable it. Second thing you need to do is enable developer mode. The devices, as they come, the developer mode is disabled, which means you're not able to run any apps that you compile yourself in Android Studio. So to enable that, this is the process. You go to, and I'll show this to you in the emulator. So basically, you find the settings app of the phone, and within settings, you go to about phone. So since this is an emulated device, I only get this about emulated device. On yours, it will say about phone. You click that, and then you find something called a build number of the operating system. So I have a build number here right at the bottom. This may look different depending upon who made the device. Samsung may show it different from LG, etc., etc. So if you don't see a build number in about phone, look for something called software information or operating system information or Android information, and inside that you will find build number. Alternatively, you could also, I believe, if you just search build number, it might show up. Okay, it did not. So I don't think it looks properly for that. So follow this about phone and then look for build number. And when you find that build number, you need to tap on it about 6 or 7 times to enable developer mode. And as you tap on it, it will tell you how many clicks away you are. See right here, it says no need, you are already a developer, because it's an emulated device. On an actual device, it will say you are 5 taps away from being a developer, 4, 3, 2, 1, etc. And then you will get it. And once that is done, you should see your device as a run target in Android Studio. So you see here, I see my device here, Samsung device, as a run target, but there is an exclamation next to it, complaining. And what is the complaint? Tells me the name of the device, which says Samsung SM A520W. And then in brackets, that's its complaint. Min SDK API 29 is greater than device SDK API 26. So my device is running API version 26. But when we created this project, you remember I asked you to leave it at the highest, the minimum SDK, and we chose 29. So that's its complaint. Well, how do we resolve it? To resolve it is simple. You go into what is called these Gradle scripts. Gradle is a build manager. Building is the process of compiling all the code you have and everything else that may go into the app. For example, multimedia, images, videos, music, the audio files, etc. It builds everything into one bundle. And this build manager has its own way of specifying things. So you'll see two files, both called build.gradle. One is for the project. You double click it, and it is sort of telling the Android Studio where to look for packages, etc., that you may be using. And there are some repositories online where it looks. You don't need to know much more than this about this particular build.gradle right now. Let's look at the second build Gradle file. And here we've got the specific information we are looking for. See, there is the application ID. This is what the Play Store would read. And if we want to change it, we'd change it here. And this is exactly what is related to the complaint min SDK. We've said our minimum SDK version is 29 and the device is running 26. So if I change this to 26, as soon as I change it, here there should be a message which says, see the one in yellow, Gradle files have changed since last project sync. Project sync may be necessary. So this exclamation mark there is there, and this is also here. So if I say sync now, let's see what happens. It says Gradle project sync is in process and it's finished. There are a couple of other messages. I'm just going to hide the tip and hide this notification. I don't want to spend time on that right now. But our Gradle sync finished, and you see the message next, the complaint is gone. Now I can choose this device and run my app. I'll show you what happens on the actual device. So it's going to compile, and you will see all the messages. They appear at the bottom, what's going on. So right now it says Gradle build running. So the build manager Gradle is running. If I click it, it will even tell me the details of what is going on in the background. So once it is done, it is going to install the app. See, now it is installing. Here it says install. And then it will launch the app on my phone. It's still installing. Let's wait for it. And you can do this, the same thing on your phone, and you will see what's happening. So this is what we see in the, I don't know how clearly you will be able to see it, but I'll open the emulator here so you can. So what you see here on the screen is exactly what it is showing on my phone now. How exciting. You can have your first app on the phone. So that is how you will develop on your device. Going forward, I will only be using the emulator because it's easier for me to show you everything that I want to show you about what we are doing. Okay, let's go back to the slides, and I'm going to go back couple of pages here and talk to you about some other things. So we have covered device emulator, we have covered folders. One thing we have not covered is this res folder. So what is in, let me just minimize the others so you have less distractions here. So there are some others, see Java, these folders were not there before. You remember we only had three, manifest, Java, and res. Res, by the way, stands for resources. So we only had resources. Now there are two more, generated Java folders and generated resources. When it says generated, it means the build process has generated some Java files for us. We don't need to be doing anything, but it does, its own thing. And here, if you expand, see there is this files under the build folder are generated and should not be edited. There is a comment here. So I'm just showing it to you for information. So ignore these generated folders. Let's go to the resources folder, expand it, and you will see there are 4 further folders inside it. There's one called values. There is one called MIPMAP. MIPMAP is a way of creating images. Layout. This is of interest to us. So what is of interest to us right now is the layout. You see this here? Okay, I think I messed this up when I changed the size of my emulator. Okay. So you see all this, how is it coming about? How did it put this hello world here? That's what we want to find out. And for that, I want you to go and look in the activity, main activity. And this here activity main XML, it allows us different ways of looking at it. Right now, you see this here at the top right, there are 3 different tabs. One is called design. This is the design mode where you see graphically, you see what all is there. So there is something called hello world. It's a text view. Text view is what allows you to place labels, text on the screen. And we have one text right in the center, which says hello world. Right here, you'll see that these are the attributes of the text label, and the attribute given to it is hello world. You could change it also. You can change it. For example, if I make it hi world, this text here will change to hi world. And if I run this program now, it will say hi world instead of hello world. So let's stick to hello world. And this is the design view. If I go into the first one, code view, this is what it is. This is the XML underlying that design. So you've got the text. You could work very well here. If you're comfortable working with XML, you could just do it here. And it's got some other things that we'll look at later on. And then there is a split view in which you have the XML, and as you make changes, you see the changes to the design. So this is both design and the code view. And within design view, you have certain options. If you need more space for design, you can hide certain elements. For example, I can minimize these attributes and I have more space. If I want to see the attributes, I can click here and they will come back. I can do the same things with this palette and component tabs, component tree, and get more space if I wanted more space. And even more space if I need, I can even hide this project navigator. The whole thing is hidden. Whenever I want, I can bring it back. I can do this. What is important for you to know here is that some of you may see this, and along with it, you may see something like this, design and blueprint. So there are 2 modes here. Within this design also, there are 2 modes, design and blueprint. And what it does is okay, how about this? Why don't you look up what the difference between blueprint and design is? You can also work with just the blueprint. So generally speaking, whatever you're comfortable with, what activity you're doing, you're going to look at it in that way. So this is what how you design that the app is, it gives you this default. Android does this for you. Whenever you create an empty activity of any kind, it puts a hello world in the middle, so you see something on the screen. Apart from that, there are other things that I think we'll run into as we go. I want to move on and look at what we have on the agenda next. We've looked at connecting your device, events, what are events, and how do we respond to them is what we are going to cover next. So far our app, yes, it runs, it opens up, it's got a title and it says hello world. It doesn't do anything else. How do apps do things? How does an app know? Let's say you're playing a game, you're doing things, or you're touching. You must have played, for example, Angry Birds or something. You pull some, you move objects using touch, etc. What is going on there? So the question is, how it happens is through events. And the question we have to look at is, what are events? So anytime you do something on your phone, for example, you touch an object, you touch a button, you touch an image, there is an event triggered. Just like you may be familiar with HTML and JavaScript. You have all those within HTML, you have on click, do this, on mouse over, do this, etc. Same philosophy here, same kind of events are generated. And the question then is, how do we respond to them? So what happens is, when there are events, there are objects which can subscribe as event listeners. So let's say there is a button, you touch it. And if there is somewhere in your code you have said that here is a listener that is going to listen to touch events on this button, that listener will get a notification, hey, something just happened, a touch was received on the button. Now do what you need to do. So let's see that in action. What we are going to do is we are going to program an event. So instead of having a very static app, what we'll do is we'll add a button to it, and then we will listen to the click event on that button. And then what we'll do is, when that click happens, we'll change the text to buy. From hello world, we'll change it to buy world or something like that. You could, of course, do many other things. That's why those touch events are listened to. In a game, you may move the object somewhere, or if that touch button was supposed to fire the Angry Bird, it will go. All those things happen through those event listeners. In our very simple app, you could, as a way of playing around, you could change the foreground or the background color of the text label, or the view, the larger view itself, which is white right now, you could change its color. So what we will do now is we'll add a button to it. Right now, our text view sits right in the center of the screen. And the reason for that is, see, regardless of the screen size, like I ran this on my phone, which does not have the same screen size as a Pixel 2, but the thing appeared right in the center. That is happening through what is called a constraint layout. This constraint layout has got these 4 constraints which look like springs here, which is what is telling the layout manager, whatever it is laying these components out, that this thing needs to be in the center. So when we add a button here, let's see what happens. So there is a button and there is a red exclamation next to it. It got added, but there is a red exclamation, and what is it saying? Let's see. missing constraints in constraint layout. This view is not constrained. It has only design time position. So it will jump to 0, 0 at runtime. So let's run this. I'm going to run it in the emulator and you will see what happens. So it's installing and now it's going to run. So this button, let's see where it went to the top left, 0, 0. It will jump to 0, 0, meaning 0, 0 in these coordinates is the top left. That's where it went. Now, if we want to prevent that from happening, then we have to properly constrain it. So this here, right now, there are no constraints on this. See, it's completely empty. And this has the constraints, the 4 constraints. So what we could do is, I'm going to, right now, I don't want to get into too much detail. So I just want you to follow along and do something with me here. I want you to hit this button which says clear all constraints. Okay. So delete all constraints in the current layout, you'll say yes. So now if we select this, it has got no constraints. This also has got no constraints. So now I want you to select by shift clicking both components and then you right click and then I want you to basically create a chain, create vertical chain. Okay. And then again right click and choose align and horizontal centers. So these two will always be center aligned. Now I can just choose any one of them and just say center horizontally. Well, it turns out I need to do both because it is expecting constraints here as well. So let's do that. Let's just center horizontally. So these are now constrained and they are constrained because we created a chain. What a chain does is it distributes space equally. So this is at 1/3 and this is at 2/3 of the height from top. We still have another complaint here, and if I click here, it is going to tell us what it is. I want you to ignore it for now. It's about how we have given the label of the button. Okay. So let's change this button to change the text of this button to change text. Okay. And what we are implementing is when we touch this button, we will change this hello world to something else. So for that, what we need is we need to listen to an on-click event. What happens when this button is clicked? For that, what you will do is you will look here, see there are declared attributes, and then there are, as you keep scrolling, you will see there are lots of other attributes. For each component, you will have access to many of these. Label may not have some of these, but they all have lots of attributes. And if you click, if you keep looking here, you see what we are looking for is something like a click, on click, something like that. This button is clickable, and the further down we go, we'll see something called on click. This is what happens on click, and this is the name of a Java function. So let's call it change text, and this means that we'll have to implement a change text function in our Java code. And as soon as I did that, it is telling me, it is complaining that corresponding method handler, let's click here. The red exclamation here, it has a problem here. On-click method does not exist. So it is expecting a declaration like this. Public void change text. I was hoping it will just give us a button here to add this code, but it doesn't matter. Just copy this. Copy this public void change text. Okay. So this is our function that we need to implement in our Java file. Let's go there. In main activity, right? This is the declaration you should have, public void change text. This is where it will come. The execution will come when that button is clicked. And what do we want to do? What we want to do is we want to change the text of the label. So how do we know what that label, how to do that? So for that, if you go back to your XML, look at the properties of the text view. You can scroll to the top, properties, attributes. I may use those words interchangeably. So attributes here, it's the first one is ID, and it's called text view, right? This is how we know. If we ask from our app, if we say, hey, layout manager, do you have an element with this ID text view? If you do, I want a pointer to it. I want a reference to it because I want to change things on it. I want to change its text or I want to change its color and things like that. So that's what we are going to do here. So to do that, what we will do is we'll first declare, okay, anytime you see this is of the type Android widget text view. And when I type it and it's not imported, you look at the top, this type is not imported. It will become red and it will give you this bubble. And at the right of it, you will see these symbols. On a Mac, this means Alt Enter. So if I press Alt and Enter, see what will happen here at the top. It imported that for me, which is good. And then what I'm going to do is find view by ID. This is an inbuilt function in this app compared activity class. It finds a view by ID, and I know the ID of that. And the way you access IDs in this framework is you just go, there is a global object called r.id. R is resources, short for resources. ID. All the IDs you have defined become a part of this object r.id, and that is what all these generated Java files they're doing for me. So when I say r.id dot, it will give me all the options or everything that is declared, and internally they are stored as integers, but you don't need to worry about that. So my text view is there. If I were to start typing text view, it will give me a completion option. I'll just press enter and there it is. So it is going to grab that. And if you look here, so if I mouse over, it tells me, it gives me the definition of whatever function calls I am making. So it's telling me that this method came from app compat activity, just like I told you. And it returns an object of type view. So let's run it now and see what happens. It should complain that this is incompatible. This is returning a view and we are assigning it to a text view. So there it is. The app is running. Now, when I say change text, it will come here and it will try to do this. Nothing is happening. Okay. So what I want to do is I want to see if the execution is in fact coming here. And like in most other languages, you are able to print things to what is called in either the console, like in JavaScript on a browser, you can use console.log statements and it prints something to the console. So here in Android, there is something called log, which is a part of Android util. And it allows us to print messages of different kinds, information, log.i, log.d for debug messages. So let's print log debug messages. And like before, log is not imported. So I will just press Alt Enter and it should appear on line 7. So it's alphabetizing them. So it got inserted between line 5 and 7. Okay, and this log.d takes two arguments, a tag and a message. So a tag is just for filtering. So I'm just going to call it testing, and a message came to click listener. All right. So now if we run it, we should be able to see whether it is actually coming here or not. And these are things. Okay, process app is running. Do you want to? So my app is already running. I'll just say terminate and it will reinstall it. And these are things slowly and gradually uh, you will need to know. Important to know how to print messages to the log. Very important skill in debugging. So this is what it has done. Now log messages, when they appear, when we run this, you see at the bottom there are all these tabs. One of them is called logcat. Logcat is where they will appear. So our message, this came to click listener. If the execution is going there, it will print in this logcat. So enable the logcat. Let's see, change text. Something is happening, but it is too fast. So see, it says here, came to click listener. There is a way you can expedite it, your search for it, by using these filter words. So this tag I gave, if I have various kinds of log messages and I want to see them at one time, if I just say testing here, it filters by that. Any lines in the logcat that contain the words or the word that you type here, that will be shown. To testing, came to click listener. It is coming here. Good. Now let's see how we can change the text view, the text. Now the problem is, see, the reason we are not getting here, it's we should be able to just say text equal to whatever text. But this is not happening because this here is returning an object of type view. And how many of you have heard of the term casting? Casting from one type to the other. Casting is what you do when in object-oriented programming, you've got parent and child classes and all that. So if you have an object that is right now of a parent class, in this case view, text view is a child, direct child, button is also a child of view. All the views are child classes of this. So this find view by ID gives us the parent view, the parent class, not the parent view, I'm sorry, the parent class. Now we want it, what it is. We know that it's a text view because we wrote it in the XML to be text view. Android Studio created it for us like that. So here we'll change this to text view, we'll assign it, cast it. Okay. Now let's try this again. Text view dot set text is what we are looking for. Set text. Okay. And here, if I say by world, hello world and by world, now let's see what happens. So I'm going to now see, it keeps asking whenever I'm already running the app on the emulator, it warns me, do you want to run it again? I'm just going to tell it to not ask me again and run it. So it is going to install again. There it is. Now let's see what happens. There it is. Changed the text. This is what you should see on your own devices or emulator, whatever the case may be. And here is some activity for you. I would like you to change the background and foreground of text view. So you can find out how to do that and do it on your own. Let's wrap this up by doing a recap. So what did you learn so far in this whole exercise of doing the Hello World app? Do some reflection on your own. What you did learn was Android Studio, basically how to, you got your hands dirty for the first time using Android Studio, how it is, what it is, how various things are laid out, what is the Java folder, the resources, the manifest. We even looked at the Gradle file to change the minimum SDK version. Android Studio did the most of the work for you in terms of creating the Hello World app, but then you went ahead and changed, learned how to add things to it. How did we add the click listener? We added a button, defined it, we gave it an on-click function like that. And we also started looking at language fundamentals, Java, fundamentals of the Java language. And if you are not very familiar with Java, I would say brush up a little. This course will focus more on mobile development, but a basic knowledge of Java in terms of how to declare variables, how to declare functions, what are classes, etc. All of that will be very useful. So I recommend brushing up on that. And actual device, if you can get your hands on one, nothing like it, your development process will be much more fun. It doesn't put as much strain on your workstation, your own computer when you're doing that. So this is where we'll stop for this app part, the Hello World part.